Howdy, this is Ramin. In this video, I'll be demoing the web server that can take requests and the load balancer that will assign requests to balance the workload of the servers, which will help maintaining optimal performance. So let's first talk about the web server. The web server is capable of taking a request and process it. There are 10 web servers initially, and as time goes, web servers will be allocated or deallocated dynamically based on the number of requests left in the queue. And then we have the requests, which are randomly generated with a range of work time between 1 to 10. And their server sizes times 100, which is 1,000 requests initially in the queue. And for the rule of adding new requests at each cycle, there's a 30% chance that a new request will be added to the into the request queue at the end of the request queue. And finally, let's talk about the load balancer, which serves for two purposes. Its first task is to assign requests in the queue to idle web servers, and its second task is to allocate and deallocate web servers based on the load. The rule that I set is that if the queue size is greater than 10 times the currently amount of servers, it will allocate a new server. And if the queue size is less than the current amount of servers, and there's more than one server currently, the load balancer will deallocate an idle server. And now let's do a demo of the program. So let me share my screen real quick. All right, so first let's run through the classes that I've built for this load balancer program. So when we go to our header files, this helper file basically helps generate a random request. So it can generate random IP as well as random request, which has a random work time. And then here's the class for load balancer. So it's capable of taking a vector of servers and then also a request queue and the total time that the user will input. And then this is the structure for the request. It has a IP address in, IP address out, and the time to work. And then this is the structure for the request queue, which is basically capable of doing some simple things like add request and to move to the next request and check its size and then if it's empty. And then we have the class for the web server, which this boolean is busy is like indicating if the web server is currently idle and whether it can take a request. And the remaining time is basically like how long will this web server take to complete its current task. Let's do a test run. So as you can see, now we have a empty log. So if I run load balancer, it's going to ask me for two inputs. The first one is the number of servers that we want, which in this case is 10. And the second one is basically asking the user how many cycles do they want. So in this case, it's 10,000. And let run. And now the log is generated. So let's run through it real quick. So first, the range for task time is basically telling you like for all the generated requests, the range for its work time. So in this case, minimum is 1, the maximum is 10. And then the starting queue size is basically the initial queue size, which is supposed to be the server, like the number of server times 100, which is 1,000. And then this is the number of cycles. So the first cycle is gonna be cycle 0. And then here's all the servers. The servers 3 is showing available because I think it took a request with work time of 1. So the first cycle finished the task, and then so it's available. And then if we move to the next cycle, we can see that it will take a remaining task in the queue. And also here a new web server has been allocated. It means that for the rule that I set for allocating a new web server, it's gonna be the server's number times 10. If the queue size is greater than that, then it will allocate a new server. So I should expect new web servers keep getting allocated until a point that yeah, until like a point the web server's number is more than enough. So here's cycle 100. If we go to like, for example, cycle 120, where the number of servers is greater than the number of queue size, it will start like deallocating the server one by one. I don't want to deallocate the servers like all at once because I want to avoid the situation where, for example, a lot of servers that finish a task at the same time, but while there's a lot of remaining tasks in the queue. So if I deallocate too much servers at once, then it's gonna have a hard time like taking the tasks basically. And yeah, that's it. That should be it for the demo, and thank you for watching.